Hi, today's videos are going to be based on the cube roots of unity. We have the equation x cubed minus 1 equal to 0. One obvious root is x is equal to 1, and therefore x minus 1 is a factor. So we could write that x cubed minus 1 equivalent to x minus 1 into x squared and x add 1 equal to 0. Now we know that x is equal to 1, or we have the solution of x squared add x add 1 equal to 0. So doing this, we have minus b plus or minus the square root b squared minus 4ac all over 2a, which is 2. So the roots of x cubed minus 1 equals 0. Therefore, 1 minus a half add root 3 over 2i, and minus a half minus root 3 over 2i. Now if you write let me rewrite that so you can actually see it. So the roots of x cubed minus 1 are 1. Let's put it here. 1. We have minus a half add root 3 over 2i, and minus a half minus root 3 over 2i. So if we were to write our equation as x cubed is equal to 1, or we can write that x is equal to the cube root of 1, we found the three cube roots of x cubed is equal to 1, or in other words, cube root of unity. Now there are two properties. One is that if we square one of these roots, we'll get the other root. So this is a quarter minus root 3 over 2i added to 3 over 4i squared, and this gives us minus a half minus root 3 over 2i. So we started with this and we square it. We have the conjugate. And the other property is if we start with minus a half minus root 3, minus a half minus root 3 over 2i, and we square this, we have a quarter add root 3 over 2i add to 3 over 4i squared, and this is equal to minus a half add root 3 over 2i. root 3 over 2i. So when we look at the complex root of unity, when we square it, it gives us the other root. So if we square one of them, it gives us the other root. And commonly, the cube roots of unity are denoted as 1 omega and omega squared. Given omega, if you square it, you'll have the other root. And we know the only real root is 1. So there are two cases of solving a cubic equation of this form. You either have 3 real roots or 1 real root and 2 complex roots, one being the conjugate of the other. Thanks for watching. I'm Alistair. Bye for now.